Hello everyone. In this video, we want to talk about anomalies that can happen in store sales volume or sales amount. The dataset is from Kaggle and it's e-commerce data, but it can be the concept that we're going to talk about is similar to any type of store and sales number. We don't have a column in the data frame if you look at the columns here, but we can use quantity and unit price and multiply them and create one column for that. So let's do that. We multiply two columns, quantity and unit price, and save it into sales column. So if you look at the head of the data frame after doing that, well, we haven't executed, which you're going to see the sale number in the last column. Now let's look at the most popular stock code in the data frame and analyze any possible anomalies for that stock ID. For that, we can use value counts and see which stock code has the most sale frequency, which is this one, 85123A, which almost has 2,300 sales. So this is like the number of sales, but sometimes it is not just number of sales. This item could be even more important because, I don't know, the price of sale is high or the margin is high. So those are the things that you can decide on your data set. But say in this example, we want to look at the this is stock ID. So we need to filter the data frame. We can use query, and we need to query the stock code for this item. So the stock code should be equal to, we can use double quotation since we use single quotation on the outer side. If we filter that now, we are going to have only this stock ID in the data frame. We can store this in, I don't know, stock. We can name it df stock and proceed with that. Now, one way of finding anomalies for sales value for the stock ID or the stock code is to aggregate the sales number for specific time windows, say weekly sales, and first visualize those numbers and see if there is a spike or there is a very rapid fall in the sales value. Then we can know yes, something happened during this week. Either this stock was stocked out, we didn't have enough in the store, or if it was a spike in the sale, we can do further analysis why we sold it too much during this week, and maybe it can happen in the near future too. So those are the anomalies that we want to watch for. So what we're going to do in the next step is to resample this data frame for weekly values, and we're going to add sales number for each week for this stock ID. And in order to resample the data frame, we should have index in date time format. So we should reindex the data frame to invoice date, and we should make sure that these are in date time format. So we'll do that in the next cell. Let's first change the format of invoice date to date time, which we can use pandas to date time and change that. And we get a warning. Yes, this is a warning because we didn't use copy in this cell. It's always a good practice to use copy when you are copying part of data frame to another data frame. If you do that, this is going to go away. Now we can change the index to this column. we can use setIndex and in place true. So right after executing the cell, the index should be changed because we used setIndex in place true, which is here. Having a datetime index is going to be really handy when you want to aggregate the data frame and get, for example, weekly sales or daily sales, because that is what is important for the manager. They want to know on average, for example, weekly averages for each store, how much is it, and is there any significant drop or raise in some of those numbers. So they don't want to look at just one data point, which is, say, these are irregular timestamps. But what we want to do is we want to look at weekly numbers or aggregated daily numbers or even monthly numbers. That's when resampling of this data frame is going to be really handy. And we can do that by df stock.resample 1 week. This can be a month or even 2 weeks or whatever window of time that you need to resample the data frame for. And if you do that, you need to also specify what is the aggregation level that you are interested. For example, we want to look at the sum of the sales or sum of the aggregations. So if you do that, it's going to do the math on all numerical columns. Obviously, you cannot do sum on or aggregation on non-numerical columns like these two columns here, or the country one. So what we are interested in is average of, not average, the sum of sales for different stores or different branches. So we can filter that for a sales column. And if you filter with just one bracket, you're going to get a Panda series. For convenience, we want Panda's data frame. So I'm going to put double bracket because I'm going to add more columns to this, anomalous numbers to different columns. Now I can store this into a new data frame. Let's say df store is equal to this. I can put a copy just to make sure it's a copy of that. And we can look at df store. Yeah, we have the df store here. So one thing, we want to look at the weekly sum of sales for the stores, but you may be interested in average. We can do the mean instead of sum. So these are average of sale per week. Maybe you are interested in maximum within each week. You can do that, and you are looking at those maximum numbers per week or minimum per week. So this depends on, like, these negative numbers, for example, could mean the return. Maybe you are interested in knowing what is the biggest return item per week. That's when you're going to use mean. So these aggregation level, I always like to look at all famous ones, at least minimum, maximum, average, and sum. All those four. And you can do even complicated equations and look at those per week. But the bottom line is, like, you need to have resample per period that you are interested in looking at, and the aggregation level, and the columns that you are interested in. Right now we are looking at just sales. Okay, let's go back to sum, and let's plot the data frame for store. We can use simply dot plot, which plots the columns, and now we have only one column, sale, and it is here. So our goal is to, for example, find these anomaly points. Some of them are observable with eyes, like there is a spike on this week, because these data are weekly, and some of them are like almost zero on this week. This is anomaly too, most probably. We want to know why this happened. The store was closed, or we didn't have the stocks, and so on. So let's numerically find these anomaly points. We are going to use unsupervised methods because we don't know the labels at the moment. No one told us what is the anomaly and what is not anomaly for historical data. It's what it is. It's just a signal that we need to know which points are not similar to normal behavior of that signal, which is, for example, this is a sales signal. For that, unsupervised methods, there are common ones like robust covariance, one-class SVM, isolation forest, local outlier factor, and scikit-learn has good implementation of these, at least 5 of them at the moment. I'm going to put the link of this page. You can Google novelty detection with scikit-learn. And I have some videos on how some of these methods are working behind the scene, like isolation forest or so. And I'm going to put the link in the description. You can watch those YouTube videos too. But let's use for example, one of these isolation forest. To do so, we can instantiate the isolation forest with contamination of 10%, which roughly says 10% of your data we believe is contaminated, and go and find those 10%. We can name this anything we want, but let's say anomaly detector, anomaly detector. And we have imported this isolation forest in the beginning of our code. So it's from scikit-learn ensemble import isolation forest. And if you execute that, you can take a look at the instance. It is isolation forest instance with contamination of 10%. Now we can fit this instance, which could be fit with, what is the data for fit? It is this data, right? So df store dot values. Now this object is trained with this data, and it's gonna behave like a model. So you can use this model to predict anomaly of any data which is close to, similar in format to the training data. And by that, I mean, it should be aggregated weekly because we already aggregated the weekly. It should be aggregated by sum because we used sum on the aggregation level. And anything that you've done in the training and preparation, you should do the same preparation, and then you can give the data to the predict. So for now, let's see what is going to happen with the same data. And why we want to pass the same data, because we want to know how this model is going to predict the old data, or which parts are going to be flagged as anomaly points. If you do that, you're going to see, for example, these -1s are anomalies. So there are normal, these points are probably normal, abnormal, and these are probably normals. So these are either 1s or -1s. It's the convention of isolation forest in scikit-learn, -1 for anomaly and 1 for normal points. But in order to visualize this, we're going to use these and plot some red dots on these -1 indexes. So if we plot the raw data plus some red points on -1 indexes, these points, you're going to have a better understanding which points are flagged as anomaly points. To create that graph, I'm going to first store these predictions into a new column in the same data frame. I can use .log, and for all rows, I can name it anomalies and look at the data after data frame. You see there is anomalies. So some of these points are flagged as anomaly points. This is probably too small number and too small number, and this is probably too large number. But anyway, we're going to visualize that. For creating those graphs also, we're going to first plot the original data frame, and then on top of that, we're going to plot those red circles. For that, we can filter just part of the data frame, which is anomaly. So we can use query, and the column name, we named it anomalies, right? So we can use query and say anomalies should be equal to -1. And let's see if we are, yeah, we can filter those, and it's going to be like 6 of those. We'll store this into df, say, anomaly. This is a new data frame that we want to plot on top of the previous one. So we can plot df anomaly. And to make it colorful, I'm going to use, probably I'm going to use O with red, which means circles with reds. And you see these points, 6 points, 1, 2, 3, 4, 5, 6. These are 6 points that we already saw in this data frame. Now you see that some of these points are very obvious to even human eye to say, yeah, these are anomalously high sales and these are anomalously low sales. Go and check to see what happened in your stock or your store, and that's about it. Now in the next session, we're going to convert these Jupyter notebooks to Python files that can be used in your MVPs, and they can be scheduled with cron jobs or converted to executable files. Those are going to be very close to a real small mini product, which are going to parse your sales data and flag anomaly weeks for managers to go and check the details of those stores or those weeks in those stores. Okay, let's look at these Python files. I have created 3 Python files, train.py, predict.py, and helper.py. Let's look at the train. We first specify the file path and pass it to a function called read clean data, which we're going to show what it is. And we have stored it in a helper file. So we are importing it here. And we're going to look at it later. But let's imagine it's going to return a cleaned data frame. And then we can use that clean data frame to train, save the model, train and save the model. So again, we're going to look at this, what it does. But again, it returns at least the trained model that we can use in the next line to predict some values, which we already saw. This is for trained or for training data set. We can predict what is anomaly or what is normal from the model perspective. And that's going to store the labels in another column, anomalies, we call them. And we're going to use the same data frame. And in the next line, we can plot those. So we have some functions we have created just for this purpose. We've stored in helper. So let's look at read clean data. It's going to be similar to what we had in Jupyter Notebook. So we read the data and we create the sale column. We already saw this. We filter for specific code. We can bring this to the argument here also, but for now it's okay. And we change the format to date time, and we set the index of the data frame to that column, and we resample for week. Again, this is usually better to have it in the argument, and you can control the behavior of this read clean data. But at the end, you're going to return df store. In the train save model, we get the clean data frame and use isolation forest to instantiate anomaly detector similar to what we saw in the Jupyter notebook. We fit these data. We fit the anomaly detector with this data, and we save it here. This is an extra step that because we're gonna load this data when we want to use it for future predictions, we need that. So we dump the object or model object to this path, which is just write the same directory. That's another thing. It's in practice, it's better to have some folder to or directory to keep your models there, but for now we use same directory. And in the plot train, we get the cleaned data frame, which is coming from probably this one. We can use better naming to match those names, but anyway, the clean data frame is gonna be used to first plot the raw data, the raw sales data, and then filter for anomalies and plot those with red circles on top of it, and then save the data. So this is going to be for train dataset plot. And in the predict.py, we're going to do similar steps. Remember what we do in train, we must do in predict. So the read clean data is almost always same steps you need to do in the train. So you're going to get the clean data, and then you need to load the data, load the model that you've saved, anomaly detector. We saved it with this name, with this path. And we're going to load it to trained model. Now, again, we can use this trained model to predict for this data set. Predict the data set that we already used it here is future data set, which is prediction data set, and we used it for cleaning. So the data can be different, but steps to clean it should be same. Now, in line 8, you have those anomaly flags, and you have stored them to the new column of this clean data. And you can use the plot train. So in fact, this is plot predict. So we can use, maybe it's better to rename this. Maybe it's better to say from helper import plot train. This is one trick that you can use as another name to just avoid confusion for later. Plot predict. Now you can use this in your plot. And we already saw all these 3 functions that we used. We stored them in helper, so it helps organizing our train and predict files. Now if you run, for example, train it's gonna execute the file for this train, and it exits with success, no error. And I have the picture here. I should be able to look at it. If I open it, it saves the data with sales.png, and it marks all these red points. Now, if I execute Python predict function, it's gonna execute all these steps, and it's gonna run the anomaly detection on this file, which is prediction underscore data. I'm gonna attach these to the Git repo, and I'm gonna link it to the below description. So if you execute that, it exits with success. And if I open the graph, now you see these are prediction data set from 2012 to January to June. And we have these diagnoses too. And that's it. Now it's time to practice, which is going to make it perfect. And I'm going to put some descriptions into Jupyter Notebook, and I'm going to put the links in the description section so you can clone and play with numbers, and put your questions, if you have any, in the comment section. Please don't forget to like or subscribe, and thanks for watching.